So the topic today is about BIM, obviously, and I titled it "Life Like Your BIM, BIM Like Your Life Depended on It," Pasadena to Mars. And you'll see a little bit more as we go through this. I'm going to be going through some very traditional kind of concepts about BIM, but also we're going to take it all the way to Mars and say what does it really mean to BIM on Mars. I'm an architect. I've been using BIM for 20 years, actually, a little bit over 20 years. It wasn't even called BIM back then, but it's very similar to what it was today, except it's kind of broadened out. There's a lot more happening in the BIM world today. Uh, so we're architects, but we're also a very different kind of company. We're also a software developer, and that happened by chance. It wasn't a planned event that we were going to go from an architectural firm to a software company, but we have become software developers as well, and you'll see a little bit more about that as well. So if you look back in time, it's really about communication. And whether we're using BIM or CAD or paper, it's about communicating an idea from one person to the next. And we stood around a campfire like this. The technology at the time was fire, and we were able to work into the night and talk into the night and share ideas. And that evolved over time, and we started to be able to capture information in many different formats. And this kind of civilization moved forward with that, made a huge leap when we were able to capture ideas and share them to the next generation, for example. So it's the concept, the technology is starting to evolve toward that, and then over time, architects. I'm an architect. I love architecture. I love everything about it. I feel we're architects, engineers, everybody in the building industry. We're at the perfect place right now. The opportunity is just massive because the world is shifting right in front of our eyes, and we're sitting right in the middle of it. We are sitting on top of things that are changing, and if we can grasp that, the opportunity is absolutely huge. There's also a lot of threats, and that's what we're going to kind of walk through today, of how can we ride that wave. So as architects, we've also captured ideas, and they were on paper and then they were on CAD. We're trying to communicate how a building comes together. And BIM is just another one of these tools. It's also a process and a workflow. That's a very important point. It's not just a tool, but we use tools along the way to capture our ideas. What does a building look like? And if you look at a document like this, those of us that are trained in it, obviously we can kind of filter out information. There's like reference bubbles and things. But it's really, again, about information, about capturing an idea and communicating it forward and being able to communicate to a big team. As we all know, buildings are incredibly complex. Cities are massively complex. The environment's getting very challenging. How do we manage this complexity without the right tools? And that's kind of where we are. These tools are shifting how we can manage our information. And if you look at a city like this, there's obviously a lot of things happening in there about energy being used. And the most important thing, I think, is that none of this is static. Everything is moving. It looks like a very static when you look at a city or a building like this. You think of things as being static, but everything is constantly on the move. The lights on, their lights are off. We're moving a wall, adding a space. People coming in, people coming out. So buildings are just constantly shifting. They're shifting, just like the wind. Maybe not as fast as it, but it is as fast. So one concept is that because things are shifting, we can't manage information like this in a static format. It has to be shifting with us. So as an architect, I think there's actually a massive problem as well. I started this BIM journey 20 years ago, literally, and before that I was into using CAD and databases, and I thought as soon as I saw BIM in 1992, 93, I thought this is it. It's going to change. In the next couple of years, things are just going to change. And unfortunately, this is what's really I've been struggling with for many years. Architects, unfortunately, have been kind of the slowest to jump on board. We've lost quite a bit of ground in the last few years because we haven't moved fast enough. So that's the opportunity. It's a huge threat, but it's also a huge, massive opportunity. Like I said. How do we capture that opportunity? So we have our ideas. We want to put them into a city. Oops, I'm going backwards here. And we want to be able to make decisions. And if you look at how we have been trained to work, even if you look at the schools today, or the way we've been trained, we kind of sit with our projects and we kind of protect our ideas and deliver them to the world. Really great. It's very challenging. It's very exciting, this concept of coming up with an idea and then sharing it outward. And then with BIM, the world is changing. The concept of sharing is important now because if you can't share, you can't innovate. And I went to a conference last week, the Lean Construction Conference in San Diego, and an CO architect presented a survey they did with their owners, and they asked them, what's the 10 most important things about you as an owner you want from us as an architect? Is it the design? Is it the cost? Is it this? No. Innovation is number one. Because people can deal with cost. We're all good designers, great designers. It's how do you innovate fast enough? Because the world is changing. You need to innovate to move fast enough to go there. So things are moving fast and faster. It's not going to slow down. Things are moving faster. So how do we, as our buildings become more complex, as we're challenged with cost, with energy, the only way we are going to solve it was with the right tools. Imagine if we didn't have books, 200 years ago, the printing press and everything. We need those kind of tools to be able to capture our knowledge and our information to be able to communicate with others. And as I go into the next set of slides here, I also want to point out that none of this technology matters at all if the people aren't connected to it, because it's not the technologies that can give us answers, us, our collective knowledge about the building industry. If we can be inside that mix, that's where we can move faster and faster. How many of you heard of disruptive technologies? How many of you have a smartphone? You're holding disruptive technology in your pocket. That didn't exist 2 years ago. It's changed everything, right? The internet has changed everything. Phones have changed everything. How we make reservations for airlines changed everything. That disruption hasn't happened yet in the building industry, but we're right at that cusp too, like what you were saying. So that again is a threat and it's an opportunity. Disruption changes things. Unfortunately, disruption comes pretty fast. And if you're not ready for it, it could run you over or you could ride that wave with it. So this is kind of a little hard to see here, but you see the shifting that's happening in everything around us. Even the fact that we're going away from desktops into mobile. Why are people running around with these now? Because these have massive amounts of information. They're very easy to use. They're on our smartphones. Smartphones have changed everything. Oh, by the way, I was asked if everybody can silence your smartphones. But I want you to have them on because we're going to actually be interacting. This is actually, I'm doing the opposite here. I'm doing the thing that I was told never to do anything live, but I always do stuff live. So later on, we're going to have some interaction with the audience, you guys. So if you have your smartphones or tablets, just have them ready. So this is very interesting. 5.9 earthquake near Richmond, Virginia. The residents in New York City read about the quake on Twitter 30 seconds before they experienced the quake itself. Just think about that for a minute. 30 seconds before the quake hit in New York, they were reading about it on Twitter. Where was that information coming from? From people saying, hey, there's a quake over here. The information traveled to the people in New York before they felt the earthquake. It's like predicting the future. So we're in a crisis. I really think, I can't stress that enough. We're in all kinds of crises, but I think architecture, engineering, the building industry, we're in a crisis because things are changing rapidly. How do we avoid the train wrecks? I talk in my presentations, I talk a lot, and you'll see this later as well. I love train wrecks. I just love train wrecks. I love to see them happen virtually before they happen in construction. I want to see them happen digitally, on paper, on CAD, on BIM, before we get on the construction site and say, whoops, I missed something. And that's a huge train wreck. And these train wrecks have to come faster at us. Another interesting quote from Steve Jobs, if you don't cannibalize yourself, somebody else will. In other words, you have to reinvent yourself before somebody else reinvents you out of the picture. So the need to innovate, the pressure is always there. We have to think like this. So education is changing. I was at a presentation 3 or 4 days ago. Rex Miller, the author of a book, he stood up in front of 200 educators, in front of 200 colleges and universities, and held up his smartphone and said, I can get courses from Stanford and MIT on my smartphone. You guys as educators, tell me why I should send my kids to your school. Obviously, it's kind of a grandstand, but it's kind of true. If you think about it, why should we send somebody to MIT if I can get similar education? So kids are asking these questions too, and education, it's not changing fast enough too. That's another disruption that's coming our way already. We've seen that in front of our eyes with, haven't you heard of Khan Academy? Go online, you get free lessons, and they flip the lesson plan around. You basically you interact in the classroom instead of doing, they're flipping the lesson. In other words, you don't go home and do homework. You do it in the classroom with a group. And it's free. You can get online and get all kinds of lessons. Some amazing things are happening. So we have to get out of the box. Think of the telephone box. We used to have to go here and make our phone calls. Now we're doing this. We're just sensors, just all over. We're changing it. We can see what's happening. We can see something happening in Boston in real time as people are watching it happen. We can see things in different ways. It's like a network, like the human body. This is actually another great site called Zygo. It used to be Google, but you can go online and see this 3D human body and kind of filter through it, see it, and point to things and tells you what it is. So information is coming at us so fast. So what do we do with all this? What happens is that revolutions are happening because of this. Revolutions are happening because people are Twittering, are able to communicate where they could not communicate before. Facebook, in the Facebook generation, every day on Twitter there's 500 million tweets. In other words, somebody's sending, well, here's an earthquake and here's this. All this information is just coming at us from people that are on the ground that used to take years to assemble and put in a book and deliver your way. So this is an amazing time to be an architect. It's an amazing time because of all this, because of these threats. I see it as an opportunity. You have to flip it around. Think of it as an opportunity. You have to be agile. You have to move fast. You have to be lean. How many of you have heard of cloud? Probably you've heard the buzzword cloud. Cloud is basically when you get on the internet, your phones, you're accessing tools, software that you don't have to install. You're basically getting a lot of data without having to have software installed on your desktop. Services-oriented architecture is another technical term that you'll see a little bit more later, but I like it because there's the word architecture in it, but it's not about architecture, about building. It's architecture about software. Software on the internet is called services-oriented. In other words, you don't go and buy an application, install it on a CD anymore. You go to your smartphone, you hit a button, and it downloads it, and you have an application, and you don't even have to install it, and you can start getting things, That's services-oriented architecture. So we will all be software developers. It's kind of a profound statement. Every one of us, if you want to be competitive in today's world, you will be a software developer. Because software is getting easier to develop. It's about our knowledge getting connected to others. If I said, if you go 10 years ago, even 15 years ago, and told somebody, you will be typing emails, we will be communicating directly, you won't have somebody typing a message for you into a letter and sending it off to somebody else. Or you'll be answering your phone directly, you won't have a receptionist screening it for you because people want to get to you. We put our cell phones on a PowerPoint now, we expect people to, if you want me, you come to me, you don't have to filter through. So that's what's happening. It's software, 12-year-olds, kids just out of elementary school are creating software for iPhones now on the weekend. There's simpler ways to create software that allows you to connect to others. We don't have this anymore. This is common sight of typewriter and messages and whatever. So, Google. I'm running through a lot of slides, so we'll take a break every once in a while to kind of decompress, but I'm going to be hitting you with a lot of images. But we want to take the building industry to the speed of Google. When you go to Google and you ask it a question, it comes back to you in nanoseconds. It doesn't take minutes even. It's not something where you go and ask it a question, you wait for 2 weeks to get something to send to you. You ask it a question and it comes back to you an answer. Something's happening in the background. Tons of stuff is happening, but you're asking a question. Imagine if we can get to our buildings at that level of information. If we could say, well, I want to point to this to get information about what's above the ceiling. That's where BIM is already there, but it's still difficult in many ways to get to the data, even if it's in depth. So we want to go there with BIM the speed of Google. Okay, when you get on, you make an airline reservation. It says, where do you want to go? Okay, I want to go to DC. Okay, well, here are some flights that are available. Here's a list of flights. Do I like that? Yes, I'm going to buy that as a contract. I just signed a contract with United to buy a seat to DC. I don't like that price. I'm going to try a different one. What seat would you like? This is a CAD or a BIM of a plane, and the seats are changing as you're making the reservation, or as others are buying the seat. So you can choose the seat that you want. It doesn't allow you to get the pilot seat. It makes it easy. You don't need 2 weeks of training or 2 years of prepping for this. You basically just log in and start working with it. And most importantly, you don't print out this airline schedule and come back to it 2 weeks later and expect to buy that seat. It's gone by that point. That's the speed of Google reservations. This is a disruption that happened to the travel industry right in front of our eyes. And now we expect nothing more than this. If somebody's told you today, you can't buy an airline seat, you have to send a request, and then 2 weeks later we'll send you your seat and your price. That's essentially what was happening a few short years ago. So we don't print out. And I actually experimented. I go to some presentations with buying 6 binders like this. And I say, here's a binder of all the flights that are available today from LA. I literally printed out all the flights. I filled a binder like this. Not even one airline. I think it was just one airline, Delta or something like that. The minute you print that binder, it's obsolete. Right? But that's how we're managing our buildings today. We're saving information about our buildings, even when we're using BIM in static format, putting it on a shelf and expecting to come back and be able to communicate in a logical way. So that's bad, but it's also incredibly good in a way that that's the opportunity that you can jump into that space, provide value back. So if you think of this as a BIM and a facilities lifecycle management tool, the technology is already there to do this. There's nothing magical about this. We've been working with the U.S. Coast Guard for a long time, especially since 9/11. It's been a very long time. One of our projects, we create strategies. That's another thing that's happened to me as an architect. It's opened an immense amount of doors for us, new types of projects and new types of clients that we have to turn work away now. We're so busy that we can select what we want to work with because we've become specialists in managing information and looking out for that information for owners. And owners happen to like that a lot. So Coast Guard is one of them. Coast Guard said the data about our facilities is more valuable than the physical facility itself. In other words, the information about this building is more valuable than the bricks and mortar of the building itself. If you look at the life cycle, and you look at what you're going to be managing in a building as far as people and energy and whatever, the actual construction costs and the design costs is like nothing compared to the life cycle. So therefore, you have to manage the information more efficiently. It's incredibly valuable to be able to do that. So here's some work. This is actually going on right now, U.S. Coast Guard Academy. It's about BIM, but it's also about facilities lifecycle management. It's about the condition of the buildings. We create an engine, and this is part of the software that we created initially for our own use internally, but now we've been licensing it out because we've had owners and others ask us to do this. This is also another very interesting thing. From the AIA, I'm part of the AIA Technology and Architectural Practice. I'm the chair of that committee. And AIA for years has talked about, oh, you can't talk about software in AIA because you're selling software. But you can have Frank Gehry stand up here and show him the building, legally managed buildings. So I'm saying that the development of software and the design of buildings is very similar. It's the same thing. We're putting information together. Therefore, we're all going to be software developers. We're processing information in a way that we're selling it to owners that has value, but it's a physical building with information about the building. And when you grab that information, you become a master of that information. This is the information age, and people pay for information. People pay money for information. Look at Google, look at that. So we have to almost disconnect ourselves from the physical building. How do we process information, package it in a way, and give it to an owner that provides incredible value if they can continue to use it? It becomes an engine. And you'll see some of the slide later on. So what we deliver to an owner is we don't deliver a PDF file, we don't deliver a binder. In fact, if they want a binder and a PDF file, we bump the price up. We say, we'll give you an iPad for free with all the information on it, or if you want a printed binder, that's going to be X amount of dollars more. So it's cheaper to actually process the information to it back in digital format. And what we deliver to them is an engine that allows them to continue to work with us. They don't have to go back 2 years later and say, these binders and these PDFs are outdated, so we have to hire a new team to go through our buildings, find out what's going on with our buildings, so we can figure out how to fix our buildings for this master plan. That cycle, unfortunately, a lot of us are part of that. We obviously make a living out of a lot of that. But it's not, owners are becoming very aware that this is not the way to do it. It's not the way to print binders of airline schedules and buy airline seats. It's about how do we interact with the owners in a way that makes us part of their ecosystem, so we're processing information for them and giving them value back. Incredible opportunity. So projects, I'm going a little fast. Am I going too fast? Are we keeping up with things? I'm throwing a lot of stuff at you, but I'm going to keep on rolling unless you have questions. So I'll pause once in a while because this is kind of a drawn-out session. But so projects, incredibly complex. You're dealing with maps, you're dealing with floor plans, you're dealing with BIM, you're dealing with energy, all kinds of tools, and you're spending an incredible amount of resources, people, and energy to put this information together to deliver that building to the owner. Then the building is complete. And all of your documents, all of our documents, all of our BIMs, all of our CADs, what starts happening is the information starts to rot because it's not maintained. It's basically a snapshot in time. It's like that airline schedule that we've saved in a PDF and put a pretty label on it, put it on the shelf. starts to rot the minute you deliver the information to the owner. It's like not putting it in the refrigerator. Then they hire other teams to come in and manage the information for them from another perspective. That's the opportunity I saw as an architect years ago. I walk away from a project, all of a sudden this huge team comes in and they basically go back into the building, measure things, put it into something, and deliver it back to the owner again. They're repurposing the information that we spent our time processing. It was our ideas as engineers and architects and builders that we processed and delivered to the owner in a way that would rot immediately so they could hire somebody else to come in and take care of it for them. So the information about our buildings that rots is not good information. There's no value to the owner other than you created a great building. So that's a problem. So we look at this, how do we capture this and think of it in terms of this information needs to cut across a lot of tools and think of it as DNA. It's the strand, the information strand of what goes on in a building. And actually years ago, it was actually right here in the Foothill chapter, we submitted a project for an award called the Object Genome Project because we've thought about this for 20 years. As we started working BIM, every BIM project we looked at, we tried to find the genetic strand of the thought of how does the school go together, how does the hospital go together, and we captured that data in a way that you can repurpose it. So you don't have to reinvent the wheel every time and say, how does a classroom go together? Well, let's sit around and talk about it. That's very fun and very nice, but it's also not value added if you have to reinvent the wheel every time. We want to spend, the only reason we built these tools and we do this way is to make it, give us more time to reflect and design. We automated everything that has zero value as much as possible so we could spend more time sketching on paper and thinking about design. There's no value in, if you imagine an Excel spreadsheet. Before Excel was around, we did things with pens and red pens and blue pens and did a calculation. And if you want to change the calculation, you went through and did it again. And you had slide rules and whatever we were using. Now with Excel, you create a formula, you change the formula, and it changes it. It gives you this iterations, right? Excel is not going to give you the engineering answer, or the mathematical answer. You have to understand as an architect and an engineer that pattern to understand what's coming out of it. Is it trash or is it good or whatever? But you're using a tool to let you see that pattern rather than having to manually calculate. That's what got us really excited 20 years ago about BIM. That got us really excited because it allowed us to be designers again. So last week, Alfred Construction, Andreas Phelps, I present with him a lot as well too. He said something very interesting at the lean construction industry. 6 months. 6 months is the shelf life of a good idea in today's age. I have a great idea. I'm going to build it next to Google. 6 months later, somebody else is going to come up with it. So that idea rots. So the goal is to share it immediately, or you lose the opportunity. In other words, you say, wow, I've got a great idea. I'm going to go over here in the corner for a year and build it, and we're going to present it out there. Somebody else has already come in and taken it away from you. That's going to happen. You might lose it by sharing it. This goes back to the school image that I showed for the studio. You don't want to hoard it. You want to share it. The more you share it in today's age, imagine those Twitter users and revolutions that happen. As you share your ideas out, you connect. And as you connect, the more connections you have, the more value you have in that ecosystem. If you hold your ideas to yourself, you become less and less relevant pretty fast. People realize it very fast. So that's an important concept as we go forward through here. Okay, so let's listen to a few things from Balfour Beatty as I take a break here. How many of you heard of BIMStorm?
It's actually my first BIMStorm, so it was a unique experience for me. It was a lot easier than I thought it would be. Basically, taking different technologies, ours, others, and making them work together in a collaborative environment. So it was pretty fun to experience and be a part of. So.
This is also a great sandbox for us to be able to essentially try out new things, to try working with new people that we might not have a chance to work with every day.
Students at different places can sometimes think that building information modeling is about one or two applications, and it's really about the ability to move information back and forth between different applications, and BIMStorm's a great example. It really gets the students excited about doing that.
We're actually at a point where we're really looking at our implementation strategy for BIM, and we thought this was the perfect opportunity to work with Kimon and some other companies to figure out what tools are out there, how do we make the data work best for us, and how do we really take advantage of improving our facilities management lifecycle with our BIM data.
When you have BIMStorm and there's no contract, you can't fail. So who cares what you do, right? But you can soar and succeed as well too. And I think that removing that constraint actually was pretty interesting.
We need to figure out where the handoff of data should occur and what data we're going to be given, and then how do we best use that with my engineers, my facility managers. Do we store it in drawings? Do we store it in our CMMS system? We have a ton of questions, and this is really helping us answer what direction should we go, what tools are out there, how do we best bring the data to life to really use it and take advantage of it.
I think the Smart Box is great. We're delivering documents and drawings and data in a structured way out to the field where the work gets done is critical.
This is what the core concept of the Vela tool does for us, is we're out in the field with our iPads or our slates, and we can go ahead and barcode scan a piece of equipment as it comes off the truck. We can mark it when it was commissioned, when it was startup.
So the fact that interoperability does work, we just need to know what the limits of it are and just get to it and do it. And that was a theme this year, right? Less talk, more action.
Yeah, I work on the technical subcommittee for the National BIM Standard, and I think there are a lot of opportunities within the National BIM Standard initiative to define discrete attributes and objects about information that need to be passed back and forth, and really provide the platform that's needed for the next generation style of collaboration that's being illustrated with BIMStorm, but even expand upon that into other domains with standardized information exchanges. So it's a great pleasure being a faculty member from Penn State. We have so many Penn State graduates within Balfour Beatty, and so I think it's really fun to be able to watch how the organization's adopting building information modeling through the years, and really providing a role model for projects that show how to integrate BIM in design, construction, and even on through to facility management.
I think what we've seen is our data coming to life, and it can be in the form of a map or a system that will track something, a system that will send another system something, and it's that you guys have taken our real life project data and put it in a tool to make it usable.
I learn something every time. I learn a lot from this. And I learn, I hope I teach, and I think we all are doing the same thing. We're learning and teaching from each other.
Okay, so Balfour Beatty is one of the sponsors of these BIMStorms. A BIMStorm essentially is a charrette, a workshop that's open to anybody. You can join for free, but we've had sponsors like Balfour Beatty jump in and actually help fund, getting things going. But this was what you saw right there was a 3-day event. We've had some that are 24 hours, and the BIMStorm started here in Pasadena. This is where it started. BIMStorms, we've had 30 BIMStorms so far in the last few years. They're not real projects, but they're based on real projects, and they can create real projects. And we invite even our competitors. We don't really see anybody as a competitor. We see everybody as a collaborator. Whoever comes in the sandbox, we play with. Whoever doesn't want to come in, then we say, okay, that's fine, come in eventually. And we see this as a way to find teams that can work well in a public setting. And it's open, the whole world can watch what's going on. See us fail, see us succeed, using them to design cities, to design buildings. And for us, for Onuma, we've actually used this as a way to find other consultants that we want to work with, or other individuals. We don't, for example, we don't accept resumes and or glossy brochures. We throw them away. It doesn't mean anything. show me how you can work. And those that show us, we form teams, and we get very interesting projects, actual projects from that. So this has been open, and it's been used by the National Institute of Building Science, and you'll see a little bit more what happens later with Mars, and essentially we're going to Mars. So we've had 30 BIMStorms around the world. 10 states. This is actually John Messner's team. One of the early BIMStorms, it was a 24-hour event, Los Angeles BIMStorm, 130 teams with multiple people around the world in 24 hours designing different things in the city. 400 and something odd buildings designed connected to them. Google Earth right here. These students at Penn State were tasked from Tim to look at it from a constructability and a cost estimating engineering perspective. So teams from around the world saying, we're putting a building here, and these guys are picking it up and saying, here's a cost estimate for that building, using BIM. With teams that had never worked with before or never met, and still have not met in many cases. So they're looking at site plans, building plans, and looking at Facebook. This generation is wired. They expect this level of interactivity and nothing less. It's like telling them, well, you need to make an airline reservation, here's a big fat catalog, go find your seat that you want on the plane. That doesn't work anymore. They expect this. This is natural. Therefore, we interact with them. And in BIMStorm LA, we had teams around the world builders jumping in and doing their thing, pushing the building. We had assignments that here's a client that wants a 500,000 square foot museum on the site. Here's a program to start using BIM and that. You'll see some more other results from that later as well. You'll see graduates from SC. Each once in a while there's a class on BIMStorm using part of downtown LA, and this is a 6-week class where we had teams doing their thing with many different tools. Again, it's no single tool that can do it all. Just like the internet is not about one app. There's going to be more applications, many more. It's not 3 or 4. There's going to be hundreds, if not thousands, if not more, about the building industry. Just like you don't have one single email application. If you don't like one email application, you throw it out and use another email application. I don't have to ask you, what email software do you use so I can send it to your software? You don't ask that question anymore. You send emails, right? Emails have been a long time, so we're bringing the building industry into this world, and the younger generation is wired for that. So we'll run through some of these exercises later, but one thing about them, we also do the very detailed construction then with flash detection, all that stuff, wonderful stuff about design and construction, but that's been there, done that. Everyone that's doing BIM is already doing that. We look at BIM at a much broader scale. We're saying you don't have to be a BIM expert to work with BIM. We don't care about your BIM capability. We care about your knowledge as an architect and engineer and designer, city planner. And we want to give you as an owner a list of spaces, square footage of the building. And we want you to take that in. This is actually Google Earth. How many of you use Google Earth? I've seen maps and stuff, but free tools essentially on the internet. There's free versions, there's paid versions. With our tool, our system is called the Onuma system. So we take an Excel file, for example, we pass it through our system, and it spits out a carpet of program. We put each of the boxes, the space of the owner said, 500,000 square foot for the Coast Guard building, the space, how many square feet, what color is the apartment, the place that has the carpet, and the task is that it's put on that site. This is about a 30-second exercise to go through here and there. And this is probably about a 30-minute exercise to start blocking and stacking. It's like sketching on paper, making sure it hasn't fit on the site. As soon as we get it to that point, we can send it off to an engineering team and say, what do you think of this from an energy perspective? How much skin do we have in the building? Which way should we rotate it? It doesn't have to be complete before you start asking the thorny questions of how much energy does it fit on the site? What about the security and standoff distance? Do we want it to be 6 stories? Do we want to split it into 2 buildings? What happens if we rotate it 60 degrees? What happens if we rotate 60 degrees and we try 300 different variations of this? What's the cost? What's the energy? All that stuff can happen way early on in the cycle. Because if you go down that road, even with BIM, if you go for 3 weeks, all of a sudden you realize, wow, that was a bad idea because the standoff distance here doesn't work, and you have to then spend 2 weeks fixing that. That's waste. So we see this is part of the rapid cycle of coming up with automatic ideas so we can go step back and say, does this make sense as a designer, and then go back and design it. It gives us more time to design because we automate the stuff that should not be done manually. And we've been going through this a lot throughout the years. We work with you on projects. We'll go through an iPhone and smartphone exercise with some of this later on as well too. But in Google, if I click on this stuff in Google, it actually pops up information. the information about BIM. This information was in an Excel file. We throw the Excel file away, by the way. As soon as we get that Excel file, that Excel file is useless because it's a static snapshot. Now everybody's looking at live data here in the cloud, and we can recreate that Excel file. It's like creating a PDF from the airline schedule snapshot, and now it's live. Then we did this exercise. We've gone through this. This is actually another building. Excel again, or from iPhone or Android. I think this is about 150-room hotel on top. There's an elevator course in the middle. We haven't imported the tenant spaces below. Nobody's touched this design yet. This is an automatically generated building in Excel. The program area when things wind up. Now we can look at it. It doesn't make sense. There's a flight path here, so we can't do it too tall to lower that building. Again, about a 30-second exercise to create these buildings. You've probably seen a lot of this with BIM. With some of the tools, the great tools are out there that start generating automatic versions of design with different skins and different Windows systems and things like that. So it's pretty exciting. This was done 3 or 4 years ago, so it's pretty old already.
When will we be able to ask the question?
Pardon me?
When
okay,
can we
I'll
ask
pause now. I'm sorry.
No, there's something that I think we all would be sensitive to, and you're really demonstrating it, is innovation, creativity depends on speed. We think so fast,
right,
and we forget what we're thinking about because the tedium that we're confronted with. Your process is taking away a lot of the tedium. You're going much faster, you're going to be more innovative.
Right.
What interests me is most of our work is in the public sector. You're working with the Coast Guard. The public sector is incredibly slow at making decisions.
Right.
What are you doing to help them with that process?
I'll actually show a little bit of that later on. That's a very good question.
That's reality.
That's reality. We're innovating, but the owner is not there yet. But the client or whoever is not there yet.
So part of the process has to be helping them.
Helping them exactly. In fact, they have a great quote from John, but that's exactly what we're basically saying. Nobody asked them to build it now, but it's not. They didn't have money, so we want some kind of computer we can hold here. I mean, that solve the need of the owner, analyze that, and create a solution. It's essentially what we do as architects. We hear an owner out and says, we want to save money, we want to have 500 students, we have to save energy. They don't tell us how to design the building. They say, well, here are the pieces that we're constrained with. And we want to say, yes, those are 3 pieces. There are 10 other things we need to consider from best practices and experience. And that's exactly right. We have to go to the owner and say, here's our great solutions. And this is the part that's frustrating me as an architect for 20 years now. Is that no owner came to me 20 years ago and said, we want to do BIM, because the word didn't even exist. They came to me and said, we want to contract you for 65 sheets of documents, 30 by 42, and we want 500 pages report on cost, 500 pages report on phasing. And we said, great. And we delivered that to them, but we used them to generate that. And we gave them the documents. We said, we want 3 perspectives, and we used 3 perspectives. Then we showed them the fly through. Then we showed them an engine. This is a 2,000 housing, Navy housing. Very complex project, master plan, lots of things. Then they said, wow, you did that. Can you do that for the next project? Sure, we'll do that. Can you do that? So we're constantly, this is how we've grown. We move a step ahead. You have to innovate. It's that 6 month thing. You look ahead and say, we'll deliver what you need today, but we're going to look tomorrow, because we're not going to solve the energy problems we have today by waiting for somebody to tell us, well, here's how you can save energy or whatever. So that's the opportunity that I was talking about earlier. I think that's the part that's exciting for me. So, but a great question, and we get that a lot too. That's a very important one, but I think it's up to us to innovate and figure out how to fit into that equation. And then owners, and by the way, I didn't introduce how big we are. We're a small company, we're 8 people. And we intentionally stay small, we've grown big, all kinds of things happening over the years, but we decided to stay small because through BIMStorm we can grow and shrink and grow as much as we want. The economy doesn't affect us at all, we just keep on rolling.
We're far more nimble.
Far more nimble. Agility is important because with this uncertainty that we have, as architects especially, I saw this, because we're always constrained by budget and fees, but we've increased our fees because we are able to provide other kinds of services to owners that have not asked for those services. And that's an important kind of business lesson, I think. And where was I going with that? So that's important, to give the owner something that they didn't expect. And this process, the BIMStorms actually, one of the reasons we do BIMStorms is because there's no constraints, there's no contract, we can do whatever we want. We can fail, we can have train wrecks, and figure out from that mess that we have in the charrette, there's a gold nugget on the wall that we're going to pull and say, here's a great idea that we're going to move forward. And we have owners coming to us that now tell us, you guys are team of A. You're going to be the prime contractor, and here's a 10,000 person firm that we want you to them to be your consultant because you guys are looking for innovators. Owners are looking for innovation, and we, as architects and engineers and designers, have that innovation in us. We've already been wired for that. We just haven't been taught that from a business perspective. If we slot into that. And the other very important piece is that no matter how large a company you are, or how small a company you are, you can't do it alone. You can't figure out how you can connect. It's like that revolution thing that I showed that happens with Twitter and Facebook. When you can start connecting, you get this magic happening with teams. And we're already used to that as well as architects. And that's what excites me. So, and when I show this slide, I get a lot of flack from architects as well. But as an architect, they say, wow, you're just automating design. No, I'm not. This is not giving me the answer. It's giving me the pieces so I can be innovative and come up with great design, just like I'm sketching with paper to come up with a new idea. So this is not the final design. It's just the pieces that the owner thought they wanted so I can react to it. So this is the result of the LA BIMStorm, 24 hours, 420 buildings. Here the building. We had kind of a master plan going on here. We set kind of the rules about this is the Chinatown area, that area, area. It's right near Chinatown. Union Station then. We had like a master plan team 2 weeks before kind of setting the form-based codes and everything. And we set heights and we basically released it like that. And then we had actual owners submitting saying, we want a school, we want a building, we want a museum. We had owners from across the country actually submitting stuff. We didn't ask LA City for permission for this, by the way, we just did it. And we also went out to LA City and we grabbed all their GIS data. We have it on the CE. We took the GIS data, we brought it into the system. So we had every single parcel and who owned and all that stuff available as a BIM so we can see what's going on with the parcel. And then teams started filling in this area and they ran out of space and started going downtown and went down the Wilshire Corridor. And they started picking places around LA and just started putting buildings up. And this is the result, inverted pyramid of all the square footage. I forgot how much square footage this is. 70 million square feet or something like that. And color-coded by you. So as the teams were designing this stuff in 24 hours, they were watching this like a barometer changing as the designs were happening. All of these are coming from multiple teams, and we're just viewing it using multiple tools, including the cloud tool that I talked about earlier, our tool, our system, and Google Earth, and Revits, and all the other things.
What was the objective? Why?
The objective was to create train wrecks, to look for teams, to experiment with constraints, and to actually maybe come up with some ideas that might be useful for the city, but that was almost secondary. It's basically, we're playing with ideas based on some real-world scenarios of some sites. And the objective was met because a lot of projects were generated, not only for us, but for other teams. We don't really care. This is about the sharing part. But if you open your door, then you get good things happening. So that's the part. And we won a lot of awards for this as well. We published a lot. This is a 30-minute exercise. After that tower that I showed you, now you start stacking it together, and you get things kind of floor plates starting to form. This is about a 30-minute exercise now. One version. The other thing that happens with these rapid iterations, just like in a charrette, it's easy to throw an idea away and say, well, that didn't work. That was 30 minutes. We'll try another one. But if you spend 30 days on it, all of a sudden you're married to that project and you can't change things. So we're trying to see how fast can we run through variations to come up with great designs. And then within that 24-hour period, that 30-minute exercise was passed to a team. This is actually in San Francisco using Bella systems. All these tools are starting to talk. That's another objective. How can software talk to each other so we can move data from one system to the next? Because I'm a software developer too, but I know software developers in the past and even today, here's their goal. Their goal is to sell you some software for a lot of money, great tool, make it very difficult for you to move your data out of their system to another system. You want to trap you in their software forever and ever and ever. That might have worked in the past, it doesn't work anymore today. I want to move, it's like going to a bank and saying the bank saying you can't move your money out of the bank. That doesn't work very well. So I say, and that's why we built our own software too. We challenge the software development concept and the concept of open standards. We want to move our data from any single tool. It's not going to be perfect all the time, but we're going to use a lot of different tools. So that building that we built that started in Excel, then went into the Onuma system, then went into Google, then went into SketchUp, then went into Revit, then all these other tools started doing things with it, looking at the scan and the windows and the energy and Ecotech, using the same data. We didn't have to translate, basically move from tool to tool. Then they took off with this in FICO, keep changing the name. FICO software, now owned by Tekla. They took it and they said, well, you're doing a steel construction. What happens if you go to concrete? We can lower the floor height, and we need a belt truss here, we need bigger foundations, but it'll lower the height of the building. Well, that might be good, but the owner might say, well, no, I want it up here for those views up here. So this dialogue starts happening. Then another team took off and did granite structure, and this is Tekla. This was happening at the same time. We were almost like competing in the show, and which one's better. And then a team took this and they went to, I think it was the Philippines, so it went around the world. They're starting to go around the world. We started in LA, and then the clock went around the world and came back the next morning with 5 different solutions within 24 hours. To this level of detail, they did the structure and everything. So this is the fast part, and the goal is not to be fast. The goal is to run through a lot of variations of sketches, and then to be able to step back and reflect and say, here's the 30th floor, and that's the lighting level of that with the floor. This is the same data that started in that Excel file now inside. Instead of doing energy analysis, all kinds.
A question, when you go back to one slide back, you go one more slide back. Yeah, the building in the middle there.
Yeah.
As an architect, you produce a building, and you can have a big connect to the structural program and spit out all the member size and all that thing, and then to the CAD system. And the CAD system to the fabricator and fabricator constructor. The team would be able to communicate all this just from your architectural building dimension all the way down to the fabricator and the record.
They're doing that, yeah, they're doing it. Have you seen that building in China that they did in 40 days? Modular building, I think it was 20 or 30. If you go to YouTube and type in Tower China 30 days, they built a tower, not this tall, maybe 20 foot tall, modular construction in 30 days. But yes, we didn't do it from here, but yes, the level of accuracy that's in that building, you could, in theory, start, and it's already happening in actual construction. If you go to some of these design build conferences, they show fabrication happening directly from the model. And it's still not perfect because there's a lot of different tools, but that's the direction it's going. That you want to be able to fabricate from models that actually engineered. And the other question that starts happening is how much should we design in the conceptual stage before you actually get into fabrication, because the fabricators might know more about how to put things together. So how far do we go with working drawings, shop drawings, to put things together? So this world is rapidly changing, and the sequential timeline that we used to have in the schematic, design, development, construction documents is merging, because we're bringing fabricators and we're starting to have discussions about fabrication maybe on day one or on energy. So it's starting to push things forward, not only in construction now, but now in our more recent project from 2 or 3 years ago, the owners are coming in and starting saying, well, how much energy or what's it going to cost to run that building if we have this kind of system that you're designing in here? Is this a good idea to put this kind of this mechanical system in here if our goal is to reduce energy or whatever it might be? So those discussions start getting merged together and happening much earlier on in cycles. We're starting to just ratchet it up. Okay, so energy, let me speed up a little bit here. And then there are other BIMStorms. This was focused on healthcare. We started in Oslo with an actual healthcare owner. They got their requirements in. We had a lot of different tools. This was a 3-day process. We started in Oslo and we moved it to Washington, D.C., and the teams kept on going. And they started doing all kinds of things like taking the programming. This is our tool again, but the programming there in Revit. Did Whitestone Research, was doing life cycle costing based on they were saying how much energy and utility costs were going to cost in that building. The first day we were starting to put that in because they had historical data of how much healthcare facilities cost to run. So they were giving us input as a designer on decisions in that stage. At Tekla, they were doing, this is again in the 3-day process, they were going to do, one team was doing kind of structural design of that. This is Gary Technology. So you can see there's a lot of different tools, and that was one of our goals, is to see how many different applications and teams can actually start playing well together. Okay, so let's pause for a second. I've been battling on and on. We had a few questions. Anything else in the back, please?
So everyone that you're showing over here, those are not real projects. Those are, with experimenting, trying to find a collaboration.
Exactly, yes. These are the BIMStorms that were not real projects, and they were done. People that participated, they do it for free, because it was amazing that people would jump in and stuff.
I'm actually impressed, because usually we don't have extra money to do this.
Exactly, yes. Yeah. And what happens is that teams from even large firms will come in, they were doing this at nighttime, for example. But those people, this is another part, as an architect, as the AI that I've been talking about as the chair of AI, you have to brand yourself, right? Even if you're part of a large company or a small company, things are going to change tomorrow. I have to know who you are. I don't care. Your company is great, but I need to find you that has that ability so I can put you together in a team 2 years from now. And that safeguards yourself. It's my knowledge about my capability. Yes, I can bring value to the team, but so that's what's happening with these team events. It's actually happened within this group, especially in the last few years. Teams just kind of went all over the place, but I still know the people that worked on that, and I can find them.
Kimon, do you think there could be so much information that at some point we humans won't be able to process it even?
Yeah.
Be able to make decisions fast enough?
Yeah, that was a good question. I don't know if you guys heard me that. There's so much information. How can we process it? As humans, yeah, we reach.
How about our capacity?
Yeah, our capacity. I think we've already reached our capacity. That's part of the challenge. It really is. If you think about it, you can't design the whole building even before BIM came around. It really is kind of a collaborative effort. So that's why you need the technology to connect the dots, and you need to be able to connect that other specialist. So everything I'm showing you here, I didn't preface this, but no single person is actually touching everything I'm showing you. There might be one person that's just focused on one thing. So when you go to an owner, they're saying we have cost, we have budget, we have schedule, we have people. This is what we care about. They don't care about how these connectors work. They just want to make sure the building doesn't fall over. So if you think of that in those terms, and you work together, then you really create this. Basically what we do as architects and teams from the past. There's nothing really magical about that. The only difference is that today there's just massive amounts of information that can't be processed.
It's important to understand, be able to sort what's relevant at the stage you're in as you develop it.
Exactly. What's relevant at that stage. And it has to come to you in a format that you don't have to spend the day kind of trying to find it. And that's what this is really about. If you think of the Google thing that I showed earlier, you're not going to the whole internet looking for that flight. You're typing in something and it's coming to you on your iPhone and just in that format. And then you know that you can buy that seat because it's connected. Something is happening in the background to buy that seat, and somebody's putting fuel on the plane and getting the flight off the ground. And I didn't say this earlier, but there's very few mid-air collisions because the airline industry is relatively efficient. But in the building industry, there's various numbers going around, but 30 to 50% of our stuff that we do ends up in some sort of a mid-air collision with cost and schedule and all that.
Fortunately, our buildings don't fly.
They don't. Yeah, exactly. But they're contributing 50% of the carbon footprint. So that's a bigger mid-air collision.
So, Kimon, can I ask real quick here? So I think, and maybe you've already thought about this, so I see this whole experimentation as a concept that's akin to software as a service from an owner's perspective, right? If I'm an owner, so let's take the Los Angeles project that you were talking about.
Right.
I'm looking at it and I'm saying, okay, the way you guys did this in a period of three days or 4 days is because you used a set of tools, right? Each one has its own capability.
Right.
But at the end of the day, you delivered a project. So to me, that's almost like saying, just like with the apps, right? I mean, if I want a specific thing, I go to this app. Right. But now next I move to another app to get the same thing done, take it to another level.
Exactly.
So you're just providing software as a service to the owner, essentially.
Exactly. It's a package, and the package is actually, it started kind of a small idea, but it's actually starting to grow. The complexity is increasing, but that service connection becomes like an ecosystem that you can, yes, deliver to the owner, but you can also replicate that system to the next owner. That's the biggest challenge a lot of times is getting the right teams and the right software together. But wrapping that software and service together.
I was looking for, because I was going to ask the next question was, what's been your experience doing this in terms of interoperability between tools?
I'll be getting into that later, but it is a challenge, but it also is not as big a challenge if you attack it in the right way. The tools are not there yet to have 100% fidelity from going from one tool to the next. You're going to lose something, even with IFCs and all the open standards. But if you're aware of what you can do, and the myth is that in theory, you want everything to go from one tool to the next, but that's impossible because each tool has its strengths. So Revit architecture does great things, Tekla Structures does other great things. We both talk about a building, but I wouldn't design structural systems in Revit, even though I could. There's Revit structural too, so you have a choice there. But that's kind of the thought process that we have, that when we're on an iPhone, we know that we're not going to fly the plane, but we can buy the seat on the plane. Right. So if we think of it in those terms, there's actually a very easy entry point. And that's what we're kind of missing a little bit, I think, and you'll see a little bit as we go through here, where we can start with that. Any more questions? I'm sorry I'm throwing notes.
No, one question. An RFP where you mentioned the client may be interested to see if they're being careful and develop a project on the BIM environment. Client is thinking of his life cycle costs. Is that the reason he wants everything in BIM? So when the project is completed, he has all the data in the BIM.
Right.
And he can assess energy cost for 30, 40 years or building improvement or building modification. Is there a reason why they ask that they be developed in the RFP?
Yeah, and a lot of clients don't know why they're asking for the things back because everyone else is asking. But yes, there's a lot of interest right now about them picking them into the life cycle. I'll be touching on that later, so I don't want to go into it.
The reason I ask because most of the times they worry about the capital costs. They don't look at the total life cycle cost.
Yeah, exactly.
Because everybody's looking at a very limited budget. And what it costs the cheapest. That's what they're looking at.
Right.
And if they look something like a BIM environment, and the bidder gonna say, hey, that's $10,000 extra for your BIM environment.
Yeah.
So then his capital cost is going up.
Right. Yes,
So
exactly.
I'm just thinking loudly why the client would be asking a proposal that this will be developed in this way.
Okay, one, there's a couple of questions. Why would a client ask for BIM if they don't think about the life cycle cost?
Yeah. If it's interested in only capital costs, he doesn't care as long as building is ready. The way the people have always been done.
Yeah. I think we have to help them with that. Obviously, it's a challenge sometimes. And then the other question is if they have to pay extra for BIM. My thinking from day one of using BIM is BIM does not cost extra. It actually costs less. If a client came to me and asked me to do a project today and not use BIM, I would say it's going to cost me more. Even if it's a small project. BIM, it's just like the discussion we started with CAD. Well, CAD, but you want to use CAD, it's going to cost more in CAD. You're doing paper cheaper. If somebody came to you today and said, we want all this mylar, handgrafted, with this kind of line weights, and we want all that stuff, it would cost more, right? We saw that from day one in BIM. BIM should not cost more. We advise clients on this because we help a lot of large owners to set the stage of this. Now when you start talking about other services, yes, it should cost more. And that's what we have to do as architects and designers and everybody else that's here. Figure out how do we provide that value back to the client. And that's the opportunity because fees are tight and all that kind of stuff. But we're thinking only in that little production mode of the documents. When really, if you think about the information mode, there's a lot more value in giving back to the clients. Do you have any questions?
Well, it seems like you're making decisions so fast. I'm wondering if you're losing information because you're changing the building so fast, and then is there something recording how we got here, why we made these decisions? Like, is that being recorded somehow?
That's a valid question. But we're making decisions so fast. Are we losing opportunities or losing decisions or why we got here? We are recording not everything, but we're recording a lot of the key pieces. And because it's not the goal is not to do it faster, it's to come up with a better solution. But the goal in this charrette is to take them out of the equation. You're throwing stuff on the wall fast, right? And you're coming, and you might even combine two ideas and come up with a new one or 100 ideas. And you're throwing a lot of other stuff away, but you can still trace back. When we do a charrette with BIM, we capture every one of those. We can filter back to that point and say, oh, we had this idea yesterday, we went this path, but now we want to go back and go down this other path. We can go back to there. And because it's digital, it actually, first of all, it makes it easier to get to that decision. And also it allows us to throw that idea out to somebody that might not be in the room and say, hey, what do you think of this from an energy perspective, a security perspective, what we're really building? So that I'm presenting stuff that shows it fast, but that's not the intent is not to say we're going to do this in one day. We're going to do that. The one-day exercise is to say what happens if we really shrink it way down, what's possible, what doesn't work. And most importantly, it allows us to step back more. We have more time to step back and just reflect on the design, stop, turn off the machine if you want, kind of look at the idea, and come back and kind of start everything. So it's not a fast, kind of, you have this kind of cycle. But that's one of the questions I always get from these presentations as an architect. I get that whole, you don't have time to reflect, you're going too fast. exactly the opposite. It's hard to see unless you try. Yeah, any questions? How do we make decisions every time? Oh yeah, it's not. It's controlled chaos.
Yeah, but you gotta have somebody who's like, here's the monitor, here's the
Right.
right.
Right. Exactly. It's just like a charade. If you take all this technology out of it, it's still the most important piece is the person making decisions. And the difference is that you're actually giving access to more people to the information. You're not hiding, not necessarily hiding. You're not making it difficult to get to it. So then somebody might say, hey, I saw that and here's another idea. And that happens all the time in the charrette and in BIMStorm.
Just a little bit to that point about cost and then about design construction in terms of the whole life cycle on what it is. The question should be the cost that clients are asking from X to Z. The question should be how much are you losing from basically going down the path to design and construction, and then at the point of open the doors and operating that building, that data just disappears.
Exactly.
That's the question.
Exactly. That's what we do with clients. When we walk into clients and you can say, even though you're looking at the first cost, you're going to sell this building, and this building's going to have information attached to it. And this information is going to show this building's not efficient with energy, and no one's going to buy it. Because what we're saying is information should be, it's the Coast Guard idea. It lives with the building. If you deliver the information to the building, the value of the building goes up. It's not, we're not there at it's not commonly understood. But if we do that, then the next group can ask the question and even see what's happened in the past and say, well, with this pattern, this building has good structure, it has good systems, and it has good information, and we can validate that. It's not just a leave platinum plaque on the wall, it's the historical data about what's actually happening performing it. I'll touch a lot more on the life cycle stuff later, so maybe hold that off a little bit, but you'll see more of that later.
So, in a way, when you're passing the building and the data to the owner, you almost have to train owner, or you have to have some kind of communication
Right.
to maintain the data.
Yeah, the question was about maintaining the data and how do you train the owner. Yes, there has to be an understanding of what to do with that. That's also another very important piece. How much is the owner capable of managing and actually deliver it? So that almost immediately becomes they need help in changing how they're currently already managing the building. Do we get the current team to transition to this, or maybe we need a new person in here to help with this, which is a huge cultural challenge because that becomes a threat to the current. It's a status quo problem. But owners, that's where we're coming in with we're educating owners that said, okay, here's the starting point you can do that with. So it's that cannibalized concept. If we don't train them how to do that, somebody else will. So if they're not doing it properly, we're trying to bring them up to speed. You'll see more of this later. I'm going to try and get through a few more of these slides, but maybe we'll hold that thought. Okay, so BIMStorm, this just happened end of last year. We had College of Architecture, University of Oklahoma, actually sponsoring this BIMStorm for actually, this was a real project that they got involved with the city planning department. It was called Core to Shore. Oklahoma City, they have a freeway coming here. They're taking the freeway out, moving it where they're moving it. That was from here to, they're moving from here to here, I think. That's the whole thing. But anyway, then they're trying to build out, this area is dilapidated. They're trying to build up the waterfront. They dammed it. They have a really nice waterfront there. So they're trying to bring the downtown area down to the waterfront. It's a big area, big ideas, lots of existing buildings. Oh, by the way, they had GIS data. A lot of cities now, all this parcel data is public data. Why not publish it on the web so I can get to it so I don't have to go get that CD? It's public data. I want to pull it into my BIM. So we pulled it directly from their server. I can click on any of these, pull up the parcel, and I can pull that into my BIM so I don't have to draw a property line. There's no reason for me to draw a property line for property line with this symbol. That's the geographic information systems and the mapping of the streets. And the buildings, the black buildings too, are in the database. So I don't have to go and recreate a model of a city if the model exists. Then therefore I can spend more time on the design. So that's what we did here, and we had students coming in and looking at energy. They were starting to site their buildings. This is again a collection of tools. They started with the R tool again, and we started. That's the simple part. We said, okay, simple, the Excel thing that I showed you earlier. Show me where you're going to put your building so I can have a discussion with you. Do we want to put it there? And show me a quick massing model so we can before you spend 2 weeks designing it, would make good sense. And then they went and they started doing more detailed design with that. So they used Revit and all kinds of other tools with that same data to move the data up. And they were graded not on the quality of their final design in this case, but for this particular exercise. They were graded on their ability to collaborate and share their ideas with others as they were going through it. We wanted to see their process, their workflow. BIM is not a lone activity. You have to be able to connect. That's what we did. And they came up with some really great designs to all kinds of themes about structure and energy and administration. And then we started placing the buildings on the site. So this is a snapshot of part of the site, Google Earth, Onuma system, Revit, and SketchUp, and paper. Paper was still used. We still use paper. In fact, we encourage it. We walk into, if we're in a room, we want to see paper flowing as well. It's about flowing the ideas, and we capture those ideas and put them into a digital format, and then starting having discussions about massing. Simple models, again, of how does it fit on the site, and then the final model, I think they use SketchUp in this case for this particular project. Okay, so that was presented to the city of Oklahoma City, the planning department. They use it in the studio, but they actually have things going on there, which means that there are opportunities in these parcels to do actual projects, and we had actual design build teams involved. And that's another thing that's been happening with these BIMStorms. As the teams start getting involved, these projects are kind of crossing the line between theoretical and real. They're getting a head start in understanding what's coming down the line so they can react to the actual projects. Okay, now we're going to go into a real project. This one involves 5,200 buildings. So California is a big state. We don't have any money, as we all know. California Community Colleges has 2.4 million students. It's almost the same population of Chicago, so it's massive. They have 24,000 acres, larger than New York City. They have 75 million square feet of space, equivalent to 32 Empire State Buildings. And they have a huge operational cost each year and a very tight budget. And as we all know, Proposition 39 with energy, all that stuff's coming. All the stuff's kind of coming together. Huge amount of energy being used, and they have 5,200 BIMs. How did they build 5,200 BIMs? This is part of the story. This is an actual project. So years ago, before we even got involved with them, 10 years ago or so, there were each district, Pasadena City College, all the districts were managing the information about their facilities using a mixture of DOS-based systems, Excel files that then were reported up to the state of how much square footage of laboratory space do you have, what's your student population, and how much budget do you need to build a new laboratory. Should we budget the laboratory in Pasadena or in San Francisco for this community college that everyone's screaming for space? So the Chancellor's office said, we're not going to even look at this unless we have a system to manage it all in one piece instead of having information silos. But each district had different ways. It's like airline reservation system in 72 different ways that you can't buy a seat with one fixed letter, so you can't roll it up. So they had information silos, and they created this system called Fusion. This is not BIM yet, but it's kind of like BIM. Fusion is a database on the web. These guys from Silicon Valley came in to help them kind of strategize and build this. And they built this statewide, so the whole state right now is in a system called Fusion. This has been happening for almost 10 years now. You can log into Fusion as a web portal. You can pull up Pasadena City College and see how many classrooms they have, what's the square footage, what's the condition of the classrooms, how many students they have, all that kind of stuff, demographics. Meanwhile, they had demographic data from around the state about population shift. So everything, moving targets, budgets changing, demographics are changing, student counts are changing, and they have to figure out how to spend budgets. And each district has their own way of doing bonds or getting money for things. So it's very complex. So what we did, and they have the shifting demographics. So this is how many of you have heard of GIS? Geographic Information Systems, essentially what Google Maps and the maps on the smartphones are. 10 years ago, GIS used to be very expensive to use or even get to. Now it's almost free in many ways. You can get online and find a map on your computer, obviously, or on your smartphones. And you can find the nearest Starbucks by looking on a map. So we're trying to think of that in terms of, if I can find a Starbucks on a map, why can't I find where the BAV box is? The same type of data, no difference. Same technology. So that's what they're thinking. How do we get data in a format that we can get to it in real time, anywhere, and look at budgets coming up, and then step back and say who should get money, basically, built. And they wanted to manage a facility's life cycle. This is way before we got involved in it. well. So they wanted to go all the way from capital planning, early planning, budgeting, going to design and construction, commissioning, operations, maintenance, the full life cycle. They wanted to capture the whole life cycle. So how do they do that? The question earlier. Do they wait for 5,200 BIMs to be completed before they can start having a conversation about energy and budget? No, that won't work. We'll sink into the ocean by the time we do that. So we said, okay, how do we tackle this? So their fusion system, they had it running as a database, and they had their geographic information system, which is mapping. And they saw what we were doing with BIMStorm. This is a direct result of a BIMStorm. The project actually related, triggered from a BIMStorm. If you guys have a system that's on the web that has graphical interfaces that you can plot buildings down with data, can you connect to our database and make our data into BIM? And we said, sure, let's try one campus. We tried one campus in about a month. We prototyped it. I'll show some of it later. And then they said, okay, that's one campus is great. Now let's try two more. We said, no, let's not try two more. Let's do the entire state. This was not their idea, by the way. The question earlier. They said, let's do one campus at a time. Prototype, pilot. We said, no. We did one. You have a database. We have a database. We're going to connect the whole database tomorrow and have the entire state because this is like the airline reservation system. Data to data. And location data. We have a tool that has a graphical interface on the web. What we could have told them, this is how software used to be built. We could have said, wow, you guys have a Fusion database, great. Give us your data, we'll put it into our system, throw away your database, and buy our system. That's not what we did. We said, you guys have a database, it's functioning. We don't want to tip the cart over. It's a functioning good database. We're going to connect to it. We're going to connect to it with a link. This is the web services concept. How the internet works, the way the internet works. The reason you can buy a Delta ticket from multiple applications is there's a Delta database somewhere that says how much the flights cost and which seat is available, not the fact that you're using the Delta application. So we can connect it to their data. We could have brought in another projects that we're working at that they don't have a database like that. So yes, we created for them. In this case, we connected to it and connected to that. And now, as they change their data, they're going out in the field and doing assessments of what's the condition of this building. We see the condition of that building in our BIM. And we have 5,200 BIMs at varying levels of detail. Kind of a wild concept, but you'll see more of this later. And we also set it up for future systems to connect to as well. We want other energy systems to connect to, many systems. And we also want consultants to connect to. So we're starting to work with other consultants that have this thinking. So now it's drawing other innovative companies into the mix that sometimes we're involved with, sometimes we're not, and they're connecting with their systems or their consulting services, their services oriented that we were talking about earlier, because they can latch onto that data and say we have an innovative solution. So this puts you as a consultant into that ecosystem. It's like if you're not on the internet and you're a bank today, you're not a bank today. If you're not on the internet and an airline, you're not an airline. You have to be in the mix to connect to others to create that value. So here's Fred Harris talking about this. This was presented a few months ago with BBN and STD, a very advanced team. BBN and STD are doing a lot of community colleges, others are as well. We come in as a consultant, we help them as well, and we help the district. And this is the Vice Chancellor, Fred Harris, Assistant Vice Chancellor, talking about the project.
Well, good morning, everyone. I'm in awe. I'm in great appreciation. Again, there's such a strength in experts in their field coming together and joining forces. It's much stronger than the individual parts. And so I guess my question to all of you is, how does it feel to be disruptive? I mean, for me, I'm usually the upstart in the room, and being disruptive comes naturally. But this notion of, as a system, creating this ecosystem that allows for these possibilities. Now, what you've seen here is just one slice, one snippet in the areas that have been focused on right now that is possible. I'm interested in hearing from all of you, and again, having this opportunity and coming together from your perspective. What are the other ways that this can be applied and can be useful? We believe this has such potentiality and benefit in terms of being this disruptive ecosystem. I mean, just the parts that I can comprehend in terms of having live layered data. How revolutionary is that? Having the ability to basically link it through web services and considering in an open standards environment how to use that data and grow it And again, it's about the data. I mean, I want to kind of touch upon, Allison's question here. It's really about the data and the structuring of the data and the use of the data. It's no longer about having a mainframe or what particular software you're using. It's having a basic browser, having, iPads, having that portability and that ability to then start thinking, going down the path of M&O. So, you're getting your budget slashed on an M&O basis because you're usually the first things to cut in a budget crisis. But, there is a certain demand, especially if you have new buildings, that people want to have a certain amount of functionality in the building. Like, would you like to have toilet paper in that building, or would you like to have the toilets cleaned, or what particular place do you want to go from there? Having the ability to gather the data and make data-based decisions is really what's going to be compelling, what this is all about. So, there's a lot of pizzazz and a lot of potential. I'm interested in hearing from all of you what it means to you and how this can be applied, because the more this platform allows for collaboration and partnership. It's inclusive, it's not exclusive. And the more that people see this and apply it from their frame of reference and bring in best practices from their point of reference, that's our R&D. That's how we grow this. And I mean, just as an example, when there were faculty and student services people in a room, I think it was at South Orange Community College District, and all of a sudden the various people, the deans and whatnot, are looking at this and going, well, we could use this for class scheduling. We could use this in a variety of other areas. And so from a frame of reference, it grows in that particular way. So there's, in one sense, there's no real entrance, if I could use the term fee. I mean, there's a minimal licensing cost, which you just blink at. But, it's a matter of being able to use this and grow it. And keep in mind, again, what we're doing is freaking amazing, not only within our system, but as I know Kimon goes around to different, groups within, the built environment around the country, I think sometimes around the world, that this is leading, if not bleeding edge stuff. So again, I congratulate all of you for your continuing support of Fusion and use of Fusion. But again, we've always thought of Fusion as being a platform to grow to satisfy even more than just state reporting needs. And so, again, I stop with this in the notion.
So that was Fred Harris. What's amazing about this is I talked about BIMStorm, the free thing that we got people involved with. We got other teams involved with this. And it took off in California and different places. Now the Department of Defense and Department of Veterans Affairs in Washington, D.C. is watching this thing. You guys are doing this in California with 75 million square feet. Why can't we do this for the whole healthcare system of 200 million square feet? Can we put this on Mars? We get questions like that. And that's all. We'll take a short break here, but that's where we're going next. We're going to show where this is actually triggering a wave that can't be done by any one company. We can't do this alone. We're looking for how we can share this. We're giving all of our secret sauce and secret formulas away because we feel this is a way to change the industry. And we're looking for that type of catalyst to happen. So we'll take maybe a 5-minute break and grab some food and drinks. We'll come back. I know there's a lot of material I'm throwing at you here, but there's more to come after we continue. All right, so the community college work, it was hitting a lot of different pieces. What Fred was talking about earlier in that animation was that they were managing facility data in a Fusion system. As soon as we started connecting their system to BIM and into our system, we starting to see the plans of the buildings show up. And just a brief overview of what we do with our system. Our system is a web-based system. It has a graphical interface with simple graphics, but it actually has a lot of data attached to it. And it is BIM, so you can click on a space and go into a room and see furniture in a room, or you can click on a space and say color-coded based on the floor finish, or color-coded based on which rooms have lights on. And you can also take it out to Google Earth and put it on a site. The most important thing about this is none of these files are actually PDFs or DWG or static plans. Everything is generated from a database, which means that if somebody changes data, we can change the color code of a room. That seems pretty simple. But we could also change even the size of the room if we wanted to. So we could say we did a renovation room and moved it this way. You'll see a little bit, and there's no single path to any of this as well too, but the important thing is that you're able to see the data without having to be trained in using BIM. And if you wanted to take this out into Revit and continue to work in it, for example, more detailed BIM work, you can actually take this data out, pull it into Revit, and continue the work. So you could start with an Excel file, for example. So here's a program environment, and here's a space, I'll take it out to BIM. Or in the opposite direction, what was happening is as the BIMs get delivered to owners, if they don't know how to use BIM, what are they going to do with the data? So we're saying bring the BIM-based data back into a system that they can see it in graphical format so they can make decisions with the data that was used to create the building, which goes back to the information concept of putting the data back in. So this has won quite a few awards as well. So here's a view of the community colleges. Each dot on the map here is a district or a campus actually, and you click on the dot and it brings up information about that campus, how many buildings it has. So this is actually a BIM on a map. And if you keep drilling down, you can get all the way to the floor plan of the building and even download the detailed model if it exists. But at the chancellor's office level, they can actually zoom back and say, where are our 72 districts? So we prototyped it in a month, and we took another month or so. By the end of 2 months, we had the whole state built like this at a low level of detail. And then we started getting pockets of stuff happening. So that's kind of the strategy, kind of go big, keep it simple, and start drilling down into details, but have it all connected across so we can drill up to the state level. Then we have 112 sites. So now districts are coming in and saying, hey, we have some CAD files, or we have some BIMs coming in, or we have no BIMs at all. If there's no BIMs at all, then the spaces actually are kind of like blocks, but we can see how many classrooms are in the building. When they have a CAD or a BIM, it starts looking like this. This is actually a very interesting view because this is typical of most buildings in the state. The data here is showing how much square footage is being reported to Sacramento as far as how big is your laboratory space. And red means that you're more than, I think it's 10% or 15% difference. In other words, you're reporting 300 square feet, but you actually have 200 square feet. And this is not intentional. This just happens over the years because they weren't using CAD. They were just using measuring tapes and writing down data and putting it into Fusion. But as soon as they connected it to a plan like this, we immediately had color codes of all the buildings that showed which ones were out of the square footage range.
Sorry to interrupt. Can you just explain Fusion a little bit?
Yeah, sorry.
Work on the CCP a little bit.
Right. So Fusion is that system that I won't go with that. Fusion is the system that Fred was explaining that has just tabular data about how much square footage you have, and there's 120,000 spaces.
So it's not drawing data.
Not drawing data. So it's data about the facility. And they also have another database that's a drawing database called ADDB, which has CAD files and PDF files. But they're not connected, they're completely disconnected. So it might be a 10-year-old plan. But what's getting reported up to the state is the condition of the space and how much square footage you have in Fusion. And what they wanted to do was they wanted to get the right amount of square footage so they can report it back up to the state. That was one goal, a very simple goal. How much square footage do we have versus what's actually on site? And by starting to combine the plans, we start seeing patterns like this. This is pretty typical. There's probably about 20% of the spaces that are out of range, which means they're not reporting the right square footage. So it's a big incentive to report the right square footage, because that's tied to budgets and planning and all that stuff.
So when you show me over there, is that a real physical floor plan or that's a diagram?
That's the real floor plan, actually. Yeah. So it's the plan. It's kind of like a shape file on top of the plan, but the difference is that it's part of that whole. If I click, I'll show the slide that you click on this, you get to this, you open this, you open this, and you can get it on an iPad too. So which means that the more people that have access to it, and you're actually using it not only to kind of park it somewhere, but you're using it to say, let's color code it based on the floor finish in this case, I think, or the occupancy, which rooms are occupied, or what's the condition of the building. So data coming in from assessments is actually changing the graphics, the BIM. And the people that are using it don't even know it's BIM. It doesn't really matter. They're just looking at a plan. But what's happening now is we're saying, okay, if we're going to hire an architect to renovate this building, we're going to give them our data from this database and say, here's our building that we have, most recent data. It's a BIM. It's in Revit. It has the right room name and room number. And we want you to deliver your CAD or BIM file back to us so it feeds back into the system rather than starting to renumber rooms. That's the biggest challenge of most owners. A lot of owners can't point to a building and say it exists or not, especially at this scale, especially at Coast Guard and other scales. There's literally buildings in a database that were torn down 10 years ago that are being paid for, whatever, all that stuff. The challenge that we have, it's a portfolio level. So that part of the ecosystem, being able to tie into a portfolio level view of an owner and be able to support them. And this is actually a project from Pancon, a project from Valkyrie that was detailed BIM was delivered back into the system. So they're no longer just kind of scattered shapes, but they're actually shapes that came from Revit, but now with their data coming back to the owner. And on top of that, some districts actually had GIS, utility data in CAD files or GIS. The state has a GIS server that has utility lines and everything. So we actually hit, this is Onuma interface. This is called a mashup. So it's the Onuma system hitting the Fusion system for the name of the space, hitting a GIS server for the utility line, hitting, I think, Google Earth for the background, whatever, and then hitting another server for the floodplain data. So it's all this data coming together, just like you're looking at Starbucks on the map. If you don't care where it comes from, you just want to find that Starbucks, and I want to find the utility line. So when I get funding for these red projects or funded projects, we can decide where to place it on the site. And as we're moving this around, stuff changes in real time as well. So next I wanted to show some, let's try some things live here. Oh, this is the part that I wanted you guys to be involved with. Okay, so pull up your smartphones. I'm going to try a little exercise. Very simple one, it's not difficult. Okay, remember I said that there's a lot of different hats and not everybody's going to touch all of this, but I just want to give you a sense of what it means to actually touch BIM data without knowing what BIM is. This works on Android, iPhone, doesn't matter, or your laptop. BIMSense.com/171. We're going to submit a work order. I know submitting a work order is not typically in our design process, but this is a result of our data being delivered to the owner so they can track the condition of their building if we give it to them in a way that they can use. And I'll walk you through this piece by piece. I could show it on the iPad, but I'm just going to open up my browser here. Okay, so let's see what's going on here. Okay, so we're live now, hopefully. Let's see if we still have internet connection. Yeah. Okay, so this is the work order system. Nothing really fancy here, but you can put your name. You don't have to put your real name if you don't want to, because this is going to come. It's a sample database, too. It's actually live, but it's a sample. You don't have to put your email address, but if you put your email address, you'll get a response back. This is the part that's significant. It looks very simple. I'm sorry, BIMSense.com/171. Okay. Anybody need more time on that? Are you okay? And I'll do this on screen too, so you don't necessarily have to do it, but if you want to, you'll actually see the result. This is the part that's significant here. This pull down are all the buildings on that campus. The ability to get to the right building name and building number seems very simple, but no owner, the California community colleges, we work with Homeland Security, we work with VA, we work with DOD, we work with Coast Guard, none of them have consistent naming and numbering of buildings. Therefore, you can't even point to a building and say we're going to renovate this building. It might take weeks to find where things are for the building. Then you get into the space. California community colleges nailed this 8 years ago. We're in California, technology's way ahead, so it's like a no-brainer. Okay, it's data. There's nothing magical about this. But we're going to just pick one building. I'm going to pick the industrial tech, or you could pick admin or any other building. I'll just pick industrial tech. And then it knows, oh, you have 2 floors in this building and a roof, because I'm hitting that database. I'm hitting a database that's essentially BIM, but I don't need to know what this is. This is BIM. I'm going to go to the first floor, then I'm going to select a space. I'm going to find an office, say 126. I'm a teacher in that office, and there's something going on here, and I'm going to say water on floor or something like that. Or you could type whatever you want. You could select any number you want. And if I had my iPad running, I could even take a photo of the water in the ceiling, and I could say urgent or whatever. And I hit submit. So that's the process. It's like 3 steps, hit submit. Nothing magical about this application, but a few years ago this used to be very complicated and very expensive to do. This particular application was built in a weekend. Created in a weekend. It's a very simple thing. It was created on a weekend because we didn't have to recreate a database about the state of California community college system and their schools and their room numbers and their building numbers. We hit their database through what's called web services, and we know that we're submitting to that space. As a teacher, that's all I need to know. Then what happens, you can do a few submittals if you'd like. Then I'm going to get, you got an error? Okay, let's see. What happened? Oh boy. Okay, let's see. Maybe we're not connected right here. Who else got an error? Did anybody get an error? Exactly. That's the other approach too. It can validate whether you're reporting from that building, because the GPS and the phone could know that. So that's what's happening with these technologies. GPS used to be very expensive, but now it's built into the phone, so you don't have to recreate a satellite system. You don't have to create a mapping system. So it's all starting to come together in a way so you can create simple applications.
let's see what happens here. So then I'm going to get the, let's see if we get, yeah, it's not letting me pick up email here for some reason.
So what does location mean after the
Oh, the location is, this is actually an interesting point too. If I'm in this building and there's no room, I'm in room 1001 and it's not in this database, maybe there was a renovation, so I could say I'm actually in room 1001. So all of a sudden I'm reporting what's happening, that this room was renovated. Remember how I said that a lot of rooms and floor plans are not accurate? Just knowing that it exists is critical to be able to service the room, to say what's missing in our database, to update it. So we're getting the people in the building to start populating the BIM data for us. So I submit, and then I'm going to see, okay, let's see what happens here. So then these are the work orders that are starting to come in. Let's see if this works. Should be connected. Yeah, there we go. Okay. 417, so we're having some coming in. So there's the water on the floor, there's hot, whatever. If I click on this, now I'm the admin. I'm putting a different hat on. Is something wrong? Did I do something wrong? It might not, I don't know if you connected or not, but anyway, this is the process. So now I'm wearing a different hat, and I'm seeing a work order coming in, and I could say, how urgent is it? So I'm adding more information here, and I could assign it to somebody. I could say I'm going to assign it to a list of people that are working for me. So I'm going to say I'm going to assign it to Amber. I could put a new person's name there. I could put their email, whatever. And I could give them, I'm going to give you 1 hour to fix this, and it's a priority, whatever. So I'm deciding what's going on there. And then right here, it's giving me a floor plan that's created on the fly that says, here's the room that report's coming from. So all these floor plans are created from a database. They're not stored. Therefore, it's like that airline seat reservation system. I can start getting feelers in from the site. And then on this floor also, if I, let's see, I have a different room here. Let's pick a different one here. Office. If there's components in the room, actually, let me give you another example. If I go to the admin office, I know that there's a first floor here. And I select a space. It has a list of equipment in the room. See, because somebody reported something's coming in the building, it's hitting the BIM database, the server, and saying there's a piece of equipment or plumbing in the room. I don't have to see the 3D model to know that there's a piece of equipment that's leaking. So it's that level of detail thing that you don't need the detailed model. And then I submit this, and basically it sends out an email to Amber. It says, go check this out. She gets an email. So different hats coming on and off here, but we're pushing that data in real time through the system. Now I know that this is not typical of what you would do as an architect or an engineer, but this is the result of your data coming back to an owner, and the owner valuing that data because now they're doing facility management without having to have a full-blown kind of complex model to deal with. So they're touching the data that you created. Does that make sense? I kind of went through quickly with that, but that's one concept.
When you were saying that you'd be able to kind of guessing there's a problem in that room, how do you guess that?
It's not a guess, actually. It's the fact that somebody reported there's something happening in room 126.
Okay.
They don't know what's in the ceiling, right? They just know there's water coming from the ceiling. So I report that 126. The admin that gets it, the admin interface that I just showed that I went through quickly, he looks at 126, then he says, what else is near 126? And there's a pull-down list that says, here's pipe, whatever, VAD.
So you actually have all the infrastructure of that facility already.
If it exists. Yeah, and it could be coming from a full-blown detailed BIM, or it could be coming just from a database that says somebody surveyed this building and this stuff up there. So it's really about, you don't have to have the same level of detailed BIMs for 5,000 buildings, but you can start managing buildings. If you don't have the equipment information, at least you know to send somebody up there and pop the ceiling open. If you have that equipment information, then you can respond to that, and you can say that we knew that leak happened a week ago, and it's in the BIM. Let's go into the 3D model and see where it is, like we see a lot of times. But you don't necessarily need to have a full 3D model to start reacting to a water.
Right, but I'm just wondering, the whole thing really depends on how reliable the information you put in.
Yes.
Like I just put in over there, so 10,001, there is something in this building, and you input in, what's the verification?
The verification is that your phone has a GPS on it, so I could verify that you're actually there. In fact, I could even restrict you from reporting that unless you're in that room because it knows where you are. And it's
we get this question a lot. It's kind of garbage in, garbage out.
Right.
But most of the times, all this data is sitting on a PDF or on a plan or a BIM somewhere. We can't get to it anyway. If you expose it, then over time, as people start touching it, it starts refining itself. We want it to feed back in, whether you're reporting a problem in the room or whether you're doing a renovation, whether you're handing this building to an architect and saying, we need to renovate this building. We've had a lot of work orders, the condition is bad. As an owner, I'm giving you that data back as a BIM, and you as the design team are giving it back to me, and it's feeding back into my system. So part of the contract, whether you're using BIM or CAD in this world, is we're giving you our list of rooms. You're going to do something with that. You're going to change the carpet or renovate this building. You're going to give us that data back, and if those numbers don't match, we reject the submittal. We don't just accept any kind of numbers room. So it's basically, we're saying, if you're going to do a room schedule, we want that room schedule to match ours. Throwing a lot of stuff at you, but the main point of this exercise is that you can start interacting with data in different ways.
Well, the first thing you said, though, is the key is a uniform numbering system.
Right.
And so then if some TI guy comes in and he's going to take 10 rooms and tear them all down and build them back into 4,
right,
then he needs to make sure that they get numbered in a way that's not another number in the room, the building someplace.
Right.
I mean, usually.
Yeah, exactly. So what happens in that scenario, just like that pull down, if they tried to number one that was already there, it would go red and say you can't number that. Give us a new number, or here's the approved. We actually line up empty numbers sometimes.
Was that your software that's telling it that?
It's a combination of ours and the Fusion, because Fusion, we don't even own the room naming and numbering. We just hit their server that says here's our room naming and numbering. So we don't have to think about that. In fact, I'll show that next, because we don't have to think. When we look at a plan, in fact, this is the plan that I was going to show you about that. This plan here is live now. And I'm coming at a different level. I'm coming from this is the state map I told you earlier. This is live now. And if I go into a click on a campus, it actually put on buildings. These are the buildings that are on that campus. The names of these buildings and the fact that this campus exists in that location is controlled by Fusion. So when I go into a site plan next, on the left side, sorry, this is kind of small here, but this is a list of that building, almost like that list that you pull down on. But now these are the list of spaces that are coming from Fusion. So if I create a BIM from this, it actually grabs the numbers from the Fusion server, which happens to be in Stockton, but I don't really care where it is. It's the official, the authoritative source of room naming and numbering that I can do something with, just like Delta is the authoritative source of seat 19A that I can buy. Very simple concept, but it doesn't happen in the building industry because we're all over the map because we have different names and numbers. So we're saying, I want to take that equation out of there, so when I talk about this building, I know how to find that room number. The other part of this is now we're live. There's certain things happening here. One is that there's a map layer, so I can turn the map layer off. And on that map layer, this is another server. I'm just turning on another server that shows the floodplain. This is a GIS map that's saying here's the floodplain for that site. And maybe I even want to look at this as a Google satellite image. And I'm hitting the Google server saying bring me your satellite images. It's just getting data from whatever source is available. And the fact that it's all latitude and longitude corrected, all of a sudden every single piece in that building has a latitude and longitude, including where that work order came in from, including where that VAV box is, including where that building is. So we're validating this stuff by location, just like we're finding Starbucks on a map.
You've been helping the Coast Guard for years. How come they got buildings that don't exist still on their server?
Because they have, I'll tell you the truth, they have very expensive old systems from 20 years ago that conflict. The numbers on one system doesn't match the numbers on another system. They're spending millions of dollars every year maintaining those systems. They can't drop them because there's different competing IT departments that say we own this part, we own that part. So it's a cultural thing and an IT problem that doesn't happen. But we're getting pockets. We're actually doing Coast Guard housing nationwide, and they're basically pulling away from that kind of closed system. So they realize it's a problem. It's a problem not only Coast Guard, but just across all agencies. They have old systems that are using different numbers, and it's like.
It's a problem for us too. Our tax dollars are going.
Exactly. That's what frustrates me. That's our tax dollars going into government maintaining buildings in a bad way. And the best thing that's probably happening right now is all the budget cuts that are happening because it's forcing owners to think, oh, we can't waste millions of dollars throwing them out the window. So who comes in to help? Well, okay, well, here we are. We can help you guys take care of. We know about buildings, not just me. I'm just talking collectively. That's the opportunity that we see. So this is the map there, and then
Then if I pull on I'm showing you a lot of different interfaces, but this essentially is showing you, okay, I want to pull up the facility condition. Red means bad. A facility condition of over 90, it means that building, it's time to tear down that building. That data is coming from teams that are going out in the field and saying what's the condition of the roof. This is other systems now talking. And if they were out in the field collecting the data, I would pull up that map, and that map would turn from green to red or whatever. I don't care where it's coming from. I just need to know what it is. And if I want to drill down and say, well, what's really going on in that building, I could actually pull it up and say, well, here's the, I don't control these numbers. So this is my software, but I don't control that number. That's coming from a financial system as far as what's the value of the building. And I could also say, give me a graph of that. So now it's going to their database, the Fusion server, hitting our server, hitting Google's graphing. So it's a bunch of tools coming together to give me a graph of this. So when I click on this thing right here, it's giving me the remaining value, and the heat generating systems have 4.5% and what the value of this. So this is multiple databases coming together in different tools, being able to view that. So it's kind of dry stuff as far as data goes, but it's very exciting because it's connected to buildings, and buildings are the interface to this. Our buildings that we design are the interface to this owner's data.
So with this community college, do you tie into this permit?
The permitting process, yeah, we've had discussions about that as well. These buildings, when they fund them, in fact, maybe we'll see one here. I think there might be one on this campus. Yeah, these buildings right here, when a new funded project comes in, it might look like this. It's just a block like that Excel file that I was talking about earlier. It says that we need a new laboratory, where are we going to put it? So that's a new building coming in, and I could decide, where do we put it? Do we put it here? Do we put it here? Oh, we have a floodplain there. That's probably not a good idea. That's the kind of stuff that starts happening. There's a seismic zone, I think, out to the left here. Yeah, the seismic fault line is right there, so we're kind of far from it. And then we also have utility lines coming in. So it's basically giving us the ability to quickly place and site buildings. And they're talking about, this is a cost reduction discussion, because they're saying, why should we spend hundreds of thousands of dollars on planning exercises if we can redo it another way? So it's bad for architects, but it's actually good because we're part of that system and we're giving them value in other ways. So it's kind of scary sometimes, but it actually gives you other things that you can do with it. And then the deficiencies, if I pull the deficiencies and I say, give me subsystems, where the plumbing fixture is failing, here's a color-coded map of which buildings have problems. So it's just getting tons of data. Then if I go into a single building, now we're in one building, same thing. Now we're at a floor plan level. Notice that the floor plan is actually very basic, but this came from a Revit model. But all I need to know is color code spaces that have floor type, whatever. So it's giving me color codes of spaces of certain floor type, and I could pull up reports and see how many square feet of this type of carpet do I have, etc. All that kind of stuff kind of starts generating in live reports from the building. So all of this data, just like the airline system, nothing is saved. None of these reports, none of these graphs, none of the Excel files, none of the BIMs even are saved as a file. It's all driven from a database because the data is constantly changing. Therefore, the CAD and the BIM files are just a static snapshot that if I wanted to look at it in different ways, I can actually export it and create a Revit model from this, or a report. And then if I pull down here to the work orders, these are the work orders that came in. The priorities, the status. This is a sample file, so I'm actually showing a lot of old files here, but it's saying filter it by HVAC or plumbing work orders. If I click on that, I can keep drilling down and say, view the work order. So I'm coming from a different angle now, not from the phone that's coming with a work order, but now from a floor plan saying what's going on, what's the condition of the space, so I can start seeing things happening from multiple angles.
Your software does what now exactly?
Yeah, it's a mixture of things. Ours is kind of the interface here, the graphical part, and the connection to the database. They have all kinds of database and maps that we connect to, but we're kind of that one of the hubs in the system in this particular case.
So to use your software, can we use the iPad, my system, or PC, or Android phone, or Windows phone?
Right. This is running on a Mac right now, but it runs on a PC, exact same. Safari, Internet Explorer, Firefox. We like Firefox, Safari better, and Chrome better than Internet Explorer. It works on all of them, but IE has kind of their own rules on the internet. We don't like it too much. But then on the iPad, we have an iPad version. We have a lot of different versions, depending on what you're trying to do. And then we also work with Revit. So from here, if I was working on this as an actual project and they gave me we need to renovate this building, I would go here, grab this, do my what ifs, because we can actually move stuff around. I can actually grab things right here and actually say, I want to place this room, you know, move it. We're going to do a renovation of this room and place it over here, for example. And then I could create a Revit model on the fly from here. But the goal here is to allow non-BIM users to say, let's place a room here. Now let's pass this to the next team that's going to do the design and engineering with it. But it comes out as a Revit model. Okay, so let's move on here. One more thing I wanted to show here was the... Okay, let's go into this building. So I'm going into... This is hitting one of the 5,000 buildings. This is we had a discussion earlier with somebody about bandwidth. The files are small, so it's kind of building it on the fly, but imagine having to download a CAD or a BIM file of each of these buildings. I'm basically hitting them as I need them and pulling up the plan. Not only the plan, but also the underlying assessment data and the condition and all that stuff that comes with it, if I can connect to the internet. And I'm able to then see what's happening with that building. I might have lost my internet connection here, which we have plans for as well. So when we go on iPads, we actually can go offline and work offline as well too. There's multiple ways of doing this. Let's see. So let's take a look at any questions. I kind of went through quite a lot of stuff here, but we have live sensors where we can turn lights on and off in the room. All kinds of stuff starts happening. Classroom scheduling, different systems starting to come together with this. Okay, so we did that. Work orders from different angles. I'm getting close to the end here. So these sensors now are starting to show what's happening in the building with work orders, what's happening with live sensor data, temperature of the building if that is available. And then for San Diego, we have BIMs coming in from design teams now. So this is the teams, the construction work that's coming back. So this is the difference, is if we have a detailed Revit model, we start getting detailed models. If we don't have anything except a PDF or CAD file, the shapes of the spaces are put in the right position, so at least we can say how many classrooms do we have in this building on the third floor. And even at that level we find errors because there's duplicate classrooms in the database sometimes that you would not notice if you're looking at a list. Very common problem for owners because they have duplicate entries or whatever, but that's where the plans start coming in because you start seeing the patterns of what's missing and what's not. So these are some of the BIMs coming from Revit back into the Onuma system.
So then as one of your things is when you notice something here, is to send a report back to the database people to say you got some bad numbers and
exactly.
They need to update them.
And where you update it from is the plan. So if you have the right login, you can click on that plan and say, we've measured this room and we're going to update it. And it updates, it goes back up to the state, to their server, to their financial systems, to their reporting systems, to all this stuff. So we're using these interfaces to update back up to the state. And that's a service that either the district does themselves or other consultants are coming in that either work with us or don't work with us and do that. But yeah, it becomes that touching point back to the owner because we're in that mix of getting these plans to submit back. So when these projects start coming in, they get submitted back into Fusion, back up to the state. And these are the live sensors. I wasn't able to get to this today. I'm kind of running out of time. But you can click on a room, and if it has a sensor, you can actually start seeing live energy data coming in and turning lights on and off. So it just goes on forever. PCC, I'm not going to show you this animation. If anybody's interested, I could point you to this, but we did a whole series of prototypes projects at PCC with live sensors and spaces. And I'm going to click through these kind of quickly, but conceptually about BIM and GIS kind of coming together. Location and buildings, you could be a dot on a map, but you could still say what kind of carpet is in that room, on that building, on that whatever. Or in other cases, I might want to see the layout of that room with that same data, saying here's that carpet and here's that piece of equipment. But at the portfolio level, I want to be able to roll up and say what's going on in the state of California. So it's a concept of not being constrained by that one container that you're working in, whether it's BIM or GIS, and being able to manage that at many levels of detail. Okay, so we're a few more minutes here and we're done. So the question earlier about what devices does it run in, it's important that the same data appears in whatever device you're using. It doesn't have to be all the data. So if I'm working in Revit, I have a different level of detail. But if I'm in an iPad and I want to see the plan of the building, I might just want to see the color code of the plan and not even care about the 3D. And the same thing with the GIS and utilities. You want to be able to get to that data in any device.
the data from there for facility management. You know, next.
So this is actually one of the buildings. This is actually from LA USD LA CCB project. It's a combined project, middle high school by I think it's HMC, delivered back to LA USD with a very detailed model. Now we connected that detailed model from Revit or Navisworks now back to the same database. So that data source of that VAV is not embedded in the model. It's coming. You pull up an iPad, it's the same piece of VAV. You pull up a Navisworks, you pull up a Revit. So conceptually what we're doing is we're saying the data should not be embedded in the file itself. It should be in a database that then you can connect to from multiple applications. Disconnect the data and make it accessible from multiple tools. And COBIe, I don't know how many of you heard of COBIe, but this is kind of a standard that owners are starting to require as a deliverable to go into operations and maintenance. It spits out a COBIe file from that same file. So we're collecting data and spitting it out in different formats. Okay, so where are they going in 5 years? This is kind of their vision. They just want to go faster at this. It's accelerating pretty. A lot of districts are coming online now with more detailed models, which means it's opportunities for other consultants and architects and engineers out there to work with the district. They're actively looking for consultants that can plug into the system. Who out there can work like this? It can't be just us. We're working with other consultants, and the districts are looking for teams out there that can work like this. It's won quite a few national awards. We've had hands-on training students who were saying students should be able to do this. There's no reason why not use it as part of the training program. Train them how to do commissioning, how to collect floor plan data. It's amazing. We had the 6-week class. I thought we were going to focus on one building. They almost did half the campus by the time we were done, just from collecting what they had and it was published. And there's a presentation on TED if you want to see it. It's about, again, California community colleges. So this generated a lot of interest. This project in California generated interest. We already worked with the government, but VA and DOD has 210 million square feet healthcare facilities. So if you can do that for community colleges, we need to do something similar for healthcare. Not necessarily to replicate, but what's the thinking, what's the strategy to move away from the static file-based system to being able to do things like this for the VA and DOD. So we're in the middle of that project right now. And they also are looking, part of our project with them is to look for consultants that can plug into the system. Because when we went to them first, they said, oh no, there's no consultant out there that can deal with data and BIM. That's not true. There's some amazing stuff happening in teams around the country that can plug in, and they're plugging in. They're saying, here's how we plug in. That's their secret sauce, basically, saying that we can talk to owners, machine to machine, and providing services that were not possible before applying facilities like this. And when you get down to it, when you get down to a piece of equipment, they have databases about equipment in healthcare. It's massive amounts of data that's impossible to manage in a manual process in building this ecosystem. So there's a whole series of things that are happening right now about this, and we're actively looking for who's out there that can plug into this and can do it. It's almost like a BIMStorm for an actual client here in this case. Program to design, yeah.
Are you ever afraid of the people that use the systems, if there are mistakes that are made? Are you able to revert back or back up your data? It would seem to me it is an incredible opportunity, but I would be so nervous if I were an owner of these data systems, allowing people access to my information. That, you know what I mean? Like, I mean, I assume everybody has a log and everybody is tracked, but it just it seems also like a security liability.
It is a security thing, but you have to be aware of who's accessing it. First of all, you know who you're logging in with. It's almost like a bank account. Yes, banks get broken into on the internet. There's security risk, but it's better than carrying $10,000 of cash in your back pocket walking down the street, which is essentially what we're doing right now with the building. So there is a risk, but if you're not in that mix, then you're not a bank on the internet. So it's that kind of concept. But yes, what happens with the errors, we see this in BIM, we prototype this in BIMStorm. When people are working together, the errors start getting fixed because if you can see them, they get fixed faster. When if you're in the corner doing this for 2 weeks, and all of a sudden you go, wow, what about this? Think about this.
You know, an analogy is Wikipedia.
Wikipedia, exactly. Yeah.
There's something like 5,000 people that actively contribute to that, and it's constantly evolving, and it's very active.
Exactly, yeah. There are mistakes along the way, but it's bigger than Britannica and all that because of that. And that's exactly how the internet works and Twitter and all that.
Well, what about less about mistakes along the way and more about like hacking and security?
Right. We get that question all the time. This was used for the Homeland Security headquarters on our server. It's kind of mind-blowing in many ways. But the way we got these projects, I walked into the Pentagon, and I said, you guys are walking around with laptops, or the VA, or whatever, and You lose that laptop, you lose everything. If I close this laptop, everything goes back up to a secure server that I don't even have to manage. I have specialists that manage that server. So I'm reducing that risk of what the worst security risk is taking the BIM, attaching to an FTP site or an email and sending us an email, which happens all the time. That's the worst security risk. Giving access only to the piece of information that you need. So I don't have to give the floor plans of the Pentagon to somebody that's going to be bidding on the carpet on the conference room of the Pentagon. They just need to see how many square feet I have. So you can fragment out what you're giving. So when you hit the Starbucks map, you're not getting access to change the satellite direction, but the satellite supporting it. That's what's happening with all this stuff. So that's the VA and DoD, and that's when we end up at the, and this is all public online, this is where we end up on Mars now. So Mars, they asked us to come in. This is National Institute of Building Science, Total Learning Research Institute, the STEM project, Science, Technology, Education, Math, teaching students, getting industry involved in the design and construction of setting up requirements of what to be built on Mars. This is based on actual data. The reason this is interesting is because it's going to allow us to try things that are not possible here on Earth, and we actually are using the same process. We're saying, what do you need to build a city on Mars? What are the elements? How much air changes do you need in that room? And if you don't have the right air changes on Mars, basically you die, right? So it's kind of a nice constraint that kind of gives you that incentive to do this right. So it's about, again, about the life cycle. So what can we learn from this? And this is open to anybody, by the way. You can go to BIMStorm.com, you get a login, you get access to the software, and you start learning. And we have videos and things that can happen. But we're looking for input from industry on this. And that's the Mars project. There's a lot of happening with that. Okay, and they're looking for sponsors too. National Institute of Science is looking for design build teams are coming in and engineers are coming in to sponsor this. So it's all about connecting, sharing, collaborating. This is what I'm like to keep it simple, think big, think agile. No single software can do it. Join us in this journey. And thanks for listening to the long session.